question addresses the use of single conductors installed in a cable tray system, specifically running from parallel link switchgear to an emergency switchboard, and whether this violates National Electrical Code sections 392.3b and 517.30c3. The answer is no, it does not violate 517.30c3. To understand this, let's examine the relevant code sections and their implications. First, it is very important to recognize that electrical codes, like the National Electrical Code, are designed to ensure safety in electrical installations. These codes specify requirements for materials, installation methods, and equipment to minimize the risk of electrical hazards. Electrical engineers and installers must adhere to these codes to protect people and property from electrical shock, fire, and other dangers. Cable tray systems are commonly used in commercial and industrial facilities to support insulated electrical cables and conductors used for power distribution, control, and communication. Cable trays provide a secure and organized pathway for these cables, protecting them from physical damage and environmental factors. They also simplify installation and maintenance by allowing easy access to the cables. NEC Section 392 covers the requirements for cable tray systems. Section 392.3b specifically addresses the types of cables and conductors permitted in cable trays. Generally, single conductor cables are not allowed in cable trays unless they are specifically approved for cable tray use. These approved single conductors are typically identified with markings like CT for cable tray use. The concern with using non-approved single conductors in cable trays is that they may not have the necessary insulation and construction to withstand the environmental conditions and mechanical stresses within a cable tray. This can lead to insulation breakdown, short circuits, and potential fire hazards. Now, let's consider NEC Section 517, which covers healthcare facilities. This section has specific requirements for electrical systems in hospitals, nursing homes, and other healthcare settings to ensure the reliability and safety of electrical power. Section 517.30c3 specifically addresses the wiring methods for essential electrical systems in healthcare facilities. Essential electrical systems are those that provide power to critical areas and equipment during a power outage, such as operating rooms, intensive care units, and life support systems. According to 517.30c3, the wiring methods for essential electrical systems must comply with specific requirements to ensure their reliability and minimize the risk of failure. These requirements typically include the use of rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved wiring methods. The key point is that 517.30c3 does not explicitly prohibit the use of single conductors in cable trays for essential electrical systems, as long as the installation meets the other requirements of the NEC, including those in Article 392 and any other applicable sections. The prohibition of single conductors in cable trays as per 392.3b is a general rule, but there can be exceptions if the single conductors are specifically approved for cable tray use or if other conditions are met that ensure the safety and reliability of the installation. The original question hinges on whether the specific installation violates both 392.3b and 517.30c3. The answer indicates that it does not violate 517.30c3. This suggests that while the installation might raise concerns under 392.3b regarding the use of single conductors in cable trays, it does not necessarily violate the requirements specific to essential electrical systems in healthcare facilities as outlined in 517.30c3. It is important to emphasize that the final determination of code compliance rests with the authority having jurisdiction, which is typically a local electrical inspector or building official. They will review the specific details of the installation, including the types of conductors used, the cable tray system, and the overall design to ensure that it meets all applicable code requirements. To ensure compliance with the NEC when using cable trays, firstly, always verify that the conductors used in the cable tray are specifically approved for cable tray use. These conductors will be marked with CT or other appropriate designations. Secondly, ensure that the cable tray system is properly installed and grounded according to NEC requirements. Thirdly, maintain proper spacing and support for the cables within the cable tray to prevent damage and overheating. Fourthly, consult with a qualified electrical engineer or inspector to review the design and installation to ensure compliance with all applicable codes and standards. The NEC is a comprehensive document, and interpreting its requirements can be complex. Consulting with experts can help avoid costly mistakes and ensure the safety and reliability of electrical installations. Let's delve deeper into the nuances of National Electrical Code Section 392.3b concerning single conductors and cable trays. This section generally prohibits the use of single conductor cables in cable trays unless they are specifically approved and marked for such use. The reasoning behind this restriction lies in several factors related to safety and the integrity of the electrical system. One primary concern is the potential for mechanical damage to the insulation of single conductors within a cable tray. Cable trays are often used in industrial environments where they may be subjected to vibrations, physical impacts, and exposure to chemicals or moisture. Single conductors, without the added protection of an overall cable jacket, are more vulnerable to abrasion cuts and other forms of damage that can compromise the insulation. This can lead to short circuits, ground faults, and ultimately, electrical fires. Another factor is the potential for overheating of single conductors and cable trays. When multiple conductors are bundled together in a cable tray, they can generate heat, especially when carrying significant electrical loads. If the conductors are not properly spaced or if the cable tray is not adequately ventilated, the heat can build up and cause the insulation to degrade over time. This is particularly a concern with single conductors, as they typically have a higher ampacity rating than multi-conductor cables of the same gauge. The NEC addresses this issue by requiring that single conductors in cable trays be deaerated to account for the effects of bundling and heat buildup. Furthermore, the use of single conductors in cable trays can create challenges with regard to grounding and bonding. Proper grounding and bonding are essential for minimizing the risk of electrical shock and ensuring the effective operation of overcurrent protective devices. When single conductors are used, it is important to ensure that the cable tray itself is properly grounded and bonded to the electrical system. Additionally, the individual conductors must be properly terminated and connected to grounding electrodes or equipment grounding conductors. Despite the general prohibition on single conductors in cable trays, there are exceptions to this rule. Firstly, if the single conductors are specifically approved and marked for cable tray use, they are permitted. These conductors typically have a more robust insulation and construction to withstand the rigors of the cable tray environment. Secondly, single conductors may be permitted in cable trays if they are installed in a single layer with adequate spacing between them. This arrangement helps to minimize heat buildup and allows for better ventilation. Thirdly, in some cases, single conductors may be installed in cable trays if they are enclosed in a conduit or other approved raceway. This provides additional protection for the conductors and helps to prevent mechanical damage. Now, let's turn our attention to NEC Section 517.30C3, which governs the wiring methods for essential electrical systems in healthcare facilities. Essential electrical systems are critical for maintaining power to essential loads during a power outage or other emergency situation. These systems typically include life support equipment, operating rooms, critical care units, and other areas where interruption of power could pose a threat to patient safety. Section 517.30C3 specifies the types of wiring methods that are permitted for essential electrical systems. These wiring methods must be reliable, durable, and resistant to damage from fire, water, and other environmental factors. Common wiring methods used for essential electrical systems include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and cable assemblies specifically listed for healthcare facilities. The key requirement of 517.30C3 is to ensure the reliability and integrity of the essential electrical system. This means that the wiring methods must be installed in a manner that minimizes the risk of failure or disruption. The NEC provides detailed requirements for the installation of these wiring methods, including specifications for support, spacing, and protection from physical damage. In the context of the original question, the issue is whether the use of single conductors in a cable tray for the essential electrical system violates 517.30c3. The answer indicates that it does not, which suggests that the installation meets the requirements of this section. However, it is important to note that the installation must still comply with all other applicable requirements of the NEC, including those in Article 392 and any other relevant sections. For example, if the single conductors are not specifically approved for cable tray use, they may need to be installed in a conduit or other approved raceway within the cable tray. Alternatively, the conductors may need to be deaerated to account for the effects of bundling and heat buildup. In addition, the cable tray system must be properly grounded and bonded to the electrical system to minimize the risk of electrical shock. To ensure compliance with the NEC, it is essential to consult with a qualified electrical engineer or inspector who can review the specific details of the installation and provide guidance on the applicable code requirements. The NEC is a complex document, and interpreting its requirements can be challenging. Consulting with experts can help to avoid costly mistakes and ensure the safety and reliability of electrical installations. Understanding the nuances of conductor types is crucial when dealing with cable tray installations. Conductors come in various forms, each designed for specific applications and environments. Single conductors, as the name suggests, consist of a single strand of conductive material, typically copper or aluminum, surrounded by insulation. Multi-conductor cables, on the other hand, consist of two or more insulated conductors bundled together within an outer jacket. The choice between single conductors and multi-conductor cables depends on several factors, including the application, the voltage level, the ampacity requirements, and the environmental conditions. Single conductors are often used in high current applications where a large conductor size is required. They are also commonly used in control circuits and other low voltage applications. Multi-conductor cables are typically used in power distribution systems, branch circuits, and other applications where multiple conductors are needed. When installing conductors in cable trays, it is important to select the appropriate type of conductor for the application. As mentioned earlier, the NEC generally prohibits the use of single conductors in cable trays unless they are specifically approved for such use. This is because single conductors are more vulnerable to mechanical damage and overheating than multi-conductor cables. However, there are exceptions to this rule, such as when the single conductors are installed in a conduit or other approved raceway within the cable tray. In addition to conductor type, it is also important to consider the insulation rating of the conductors. The insulation rating indicates the maximum voltage that the conductor can safely withstand. The insulation rating must be appropriate for the voltage level of the circuit in which the conductor is used. Furthermore, the insulation must be resistant to the environmental conditions in the cable tray, such as moisture, chemicals, and temperature extremes. Another important consideration is the ampacity of the conductors. The ampacity is the maximum amount of current that the conductor can carry without overheating. The ampacity of a conductor depends on its size, insulation rating, and the environmental conditions. The NEC provides detailed tables that list the ampacity of various types of conductors under different conditions. When selecting conductors for a cable tray installation, it is important to ensure that the conductors have sufficient ampacity for the load they will be carrying. Additionally, the conductors must be deaerated if they are installed in a bundled configuration or in an environment with high ambient temperatures. Deaerating involves reducing the ampacity of the conductors to account for the effects of bundling and heat buildup. This helps to prevent the conductors from overheating and damaging the insulation. Proper installation techniques are also critical for ensuring the safety and reliability of cable tray installations. The cable tray system must be properly supported and grounded to prevent mechanical damage and electrical hazards. The conductors must be installed in a manner that minimizes stress and strain on the insulation. The conductors must be properly terminated and connected to the electrical equipment. All connections must be tight and secure to prevent loose connections and overheating. Regular inspection and maintenance are also essential for ensuring the long-term reliability of cable tray installations. A cable tray system should be inspected periodically for signs of damage, corrosion, or loose connections. The conductors should be inspected for signs of wear, abrasion, or overheating. Any damaged or worn component should be replaced promptly. In addition to visual inspections, it is also important to perform electrical testing to verify the integrity of the cable tray system. This testing can include installation resistance tests, continuity tests, and ground impedance tests. These tests can help to identify potential problems before they lead to failures or hazards. By following proper installation techniques and performing regular inspection and maintenance, it is possible to ensure the safety and reliability of cable tray installations for many years. Remember to always consult with a qualified electrical engineer or inspector for guidance on the applicable code requirements and best practices for cable tray installations. The NEC is a complex document, and interpreting its requirements can be challenging. Consulting with experts can help to avoid costly mistakes and ensure the safety and reliability of electrical installations. Additionally, consider the physical environment where the cable tray is installed. Factors such as temperature, humidity, and exposure to corrosive substances can impact the longevity and performance of the cables and the cable tray system. Select materials that are suitable for the specific environment to prevent premature degradation and ensure reliable operation. Proper labeling and documentation are also crucial aspects of cable tray installations. Clearly label all cables and conductors to facilitate identification and troubleshooting. Maintain accurate records of the cable tray layout, conductor types, and circuit assignments. This information will be invaluable for future maintenance and modifications. Consider using cable management accessories such as cable ties, clamps, and dividers to organize and support the cables within the cable tray. These accessories can help to prevent tangling, abrasion, and other forms of damage. They can also improve the overall appearance and maintainability of the cable tray system. When making modifications to an existing cable tray system, be sure to follow proper procedures and adhere to all applicable codes and standards. Carefully plan the modifications to minimize disruption to the existing electrical system. Use qualified personnel to perform the work and thoroughly inspect the completed installation to ensure that it meets all requirements. Finally, stay informed about the latest developments in cable tray technology and industry best practices. Attend training courses, read technical publications, and participate in industry events to expand your knowledge and skills. This will enable you to make informed decisions about cable tray installations and ensure that your projects are safe, reliable, and compliant with all applicable codes and standards. Let's consider the role of the authority having jurisdiction, often abbreviated as AHJ. The AHJ is the entity responsible for enforcing the requirements of the National Electrical Code and other applicable codes and standards. The AHJ can be a local electrical inspector, a building official, or another designated authority. The AHJ has the final say on whether an electrical installation complies with the applicable codes and standards. It is important to work closely with the AHJ throughout the design and installation process to ensure that the project meets all requirements. The AHJ can provide guidance on code interpretations, review plans and specifications, and conduct inspections to verify compliance. In some cases, the AHJ may require additional documentation or testing to demonstrate that the installation meets the code requirements. It is essential to address any concerns or issues raised by the AHJ promptly and professionally. Failure to comply with the AHJ requirements can result in delays, fines, or even the rejection of the project. To avoid these problems, it is best to establish a good working relationship with the AHJ and to communicate openly and honestly throughout the project. Keep in mind that the AHJ primary goal is to ensure the safety of the public and the integrity of the electrical system. By working together, it is possible to achieve this goal while also completing the project successfully. Furthermore, consider the impact of future expansion or modifications on the cable tray system. Design the system with sufficient capacity to accommodate future needs. This may involve installing larger cable trays or providing additional raceways for future cable runs. Planning for future expansion can save time and money in the long run by avoiding the need to replace or modify the existing cable tray system. When selecting cable tray materials, consider the environmental conditions and the potential for corrosion. Aluminum cable trays are a good choice for corrosive environments because aluminum is naturally resistant to corrosion. Steel cable trays can also be used in corrosive environments if they are properly coated with a corrosion-resistant material. Stainless steel cable trays offer the best corrosion resistance but are also the most expensive. Choose the material that provides the best balance of corrosion resistance, strength, and cost for the specific application. Always refer to the manufacturer's specifications and installation instructions for the cable tray system and the conductors being used. The manufacturer's instructions provide valuable information on proper installation techniques, load ratings, and other important considerations. Failure to follow the manufacturer's instructions can void the warranty and may result in unsafe or unreliable installations. In addition to the NEC, there may be other applicable codes and standards that govern cable tray installations. These may include local building codes, fire codes, and environmental regulations. It is important to be aware of all applicable codes and standards and to ensure that the installation complies with all requirements. Continuing education and professional development are essential for staying up to date on the latest developments in electrical codes and standards. Attend training courses, seminars, and conferences to expand your knowledge and skills. Read industry publications and participate in online forums to learn from other professionals. By staying informed and engaged, you can ensure that your cable tray installations are always safe, reliable, and compliant with all applicable requirements. The original question concerned the specific scenario involving single conductors in a cable tray system running from paralleling switchgear to an emergency switchboard. While the general answer is no, 517.30c3 is not violated in the described scenario, it's critical to reiterate that code compliance is highly context-dependent. The specific types of conductors, the exact installation methods, and the overall system design all play a role in determining whether an installation meets the NEC requirements. Therefore, always consult with qualified professionals and the AHA to ensure compliance in any given situation.